Okay. Now we begin the second part, and okay. So I'm Hsuan-Chih Wang Xuanzhi, and you can call me Leo, and I'm currently an associate researcher at Intelligence Persistence Center, China Engineering Consultant. In this part, the project like I used to practically participated in is all done during my research work at NCKU and when I was a traffic engineer at NCKU. And okay, this is the second part. Okay, there are three projects that I would like to share. And the first is a signal-based and timing service in Tainan City. This is my undergraduate project. And the second is V2X-based emergency vehicle signal preemption system. It is a proof of concept project that was done during my graduate school. And the third one is a V2X-based multi-model traffic signal priority system in Tainan City, and this is a real-world project, and it is implemented on 21 signalized intersections. And the last part, I will share the lessons I learned and the conclusions. Okay, we started with the first one. Okay. This is a signal-based and timing service in Tainan City, so you might have known that the spot information signal-based and timing message is an application of connected vehicle, and you can know the signal timing information of the intersection in front of you. And okay, before we start describing it, I would like to mention there's a virtual traffic control center in National Taiwan University, and it is typically a backup system of the Tainan Traffic Control Center, and through a VPN network, so we can access the signal timing database in the Tainan Traffic Control Center. And then I use it to achieve the goal of presenting the signal-based and timing information. I simply made up an Android application to do it. And the one assumption in the Tainan City is that almost all intersections in Tainan City are TOD controlled, so they are non-actuated. So I can predict the remaining time and the phase. So I can show the traffic light the remaining time of that phase by simply calculating it. Okay, so this is the structure of this app. So you can see this is the app that I designed. So this will show the intersection of the in front of the driver, and then the current light, and the remaining seconds. So the first step is we need to know the target intersection. The target intersection is the intersection that's in front of the driver, and we will need to measure driving direction with Face ID. So we will know these two information, and then we can get the instant time of the driver, and then we know the segment ID. And with all this information, we can send a query to a signal timing database, and this database will return the signal timing data, and we can calculate the remaining time, the current signal phase, and show the information on the app. Okay, the first step is you need to know the target intersection, because you're the driver. There are many intersections in front of you. Which one will be the intersection that exactly in front of you? That is the problem. So I designed a simple algorithm to find out which intersection is in front of you. It's simple. The step one is I will draw a detection area according to your current location, your GPS information. And this area, I will list all intersections that are located in this rectangle area and calculate the distance to each intersection in the list and choose the shortest one as the target intersection. And the next step is we need to match a direction with space ID. And this problem is like in this scenario, there are two intersections in this scenario, and in this intersection, the phase one is west-east direction, and the phase three is north-south direction. And in this intersection, the north-south direction is phase one, and east-west direction is phase two. So if you are a driver that driving from north towards south, and at this intersection, you need the information of phase three, and in this intersection, you need information of phase one. So we need to match the direction of your phase. So I typically separate it into 8 directions, and each direction will be 45 degrees. Okay, and then you need to know the signal timing plan, the ID of the signal timing plan. So in Taiwan's controller, we typically separate it into 15 segments, and then we can retrieve the plan ID by mapping the current time to the time segment ID, and then we will know what the traffic controller is running, the plan that the traffic controller is running. For example, if currently is 9 o'clock, so it is running segment 5, and then the corresponding plan ID is 2. So we will retrieve the signal plans in the database of plan ID 2. Okay, so this is what you will see in the signal timing database. So typically there are several information. The first is this intersection ID and the intersection name, and the phase order, as we mentioned in the previous class. This is the phase order, and the plan ID, the phase ID, the green time, the yellow and orange time, and pedestrian green, pedestrian red. And this is the direction, and this direction is self-designed, as I mentioned earlier in the previous slide. So typically you can see this. For example, it's a plan ID 4, and there are 2 phases, and the phase 1 is the green time is 80, and the second phase is 30. So there's a direction I have setting up. So if the driver is driving the vehicle and use my service, my app can calculate the right phase according to his or her direction. Okay, so this is an example how I calculated. So at this intersection, there are 2 phases. The phase 1 is on Shengli Road, and the phase 2 is the side entrance of Huangfu campus. So as I mentioned, if you are driving on the Shengli Road, so you need the information of phase 1 rather than the phase 2. So you need my application will calculate the phase 1 and calculate the remaining times and show the right information on the app. So this is a simple example of how this works. So you can see that there's an app and I was using, and it will detect the information in front of your vehicle. Like this intersection, it will show the intersection name and the intersection ID and the current light and the remaining time through the calculation process that I mentioned earlier. So you see somebody violate the red light. This is common in Tainan City. So okay, so you will know the remaining time of the signals, and it will automatically calculate after you leaving the intersection, it will detect the next intersection information. Okay, we'll just wait. It's calm down. Okay, you see there's a little bit delay because there's a bug in my application, so you'll see a delay. Okay, this is the first project that I done. And this the second one is a V2X based emergency vehicle signal preemption. And this is a proof of concept project. Okay, the background of the system is that we want to design a next generation smart traffic signal control system. And this system, we expect it will support various smart city applications such as emergency vehicle signal preemption, transit signal priority, adaptive traffic signal control, or some spot information for CAV applications. So we want a signal control system that can support all these various applications. Okay, so this is a structure of our system, and you can see this is a traffic controller, and typically we have RSU roadside unit, a industrial computer in it, and we have several plugins such as GPS, changeable message sign, vehicle detectors, or the DSRC module, V2X module. So this module can connect to the cloud center, and also we have onboard units on our vehicles to they can connect, they can communicate with the V2X application. Okay, so this is software architectures. Our design is this part is the external modules like vehicle detectors, changeable message sign, and this is a hardware layer and the OS layer with a Linux-based system, and the middleware, and then the top one is the application layer that support like adaptive transit signal control, transit signal priority, or something like that. Okay, so in this system, we only implement the emergency vehicle signal preemption, and this is the scenario of our system. We can see there's an EV, emergency vehicle, riding from south toward north, and this is the detection area of the our RSU roadside unit. And when it enter the detection area, and the system will be activated. And for example, this is a red truncation scenario, so it will truncate the red light. Currently, there's a red light, and then become the green light. And also, there's a new design in our system. We will, after the truncation, we will make the yellow blinking. The yellow light will keep flashing during the whole EVSP system. And there's a demo video, so you can clearly see how it works. So the green detection is more simpler. You can see the same scenario, and it's just extend the green time, and also it will have a yellow blinking in the system. Okay, this is our test field. This is in Tainan Pinshi redevelopment zone. There's an intersection, and we simply implemented our system in this intersection. Okay, you see the traffic controllers here, and this is how the pre-processing work. First, you see in this in this picture is clear, right? But the first time we visited here is not the case. You see there's a lot of grays, and so we need to weeding and keep weeding, and during the whole process, we will change the signal setting and also set the parameters. Okay, so this is some pictures of our pre-processing work. We also installed tunable message signs, and we implement a onboard unit on a vehicle, and we implement the system on the controller. So this is a demo video, so you can see how it works. This is a demonstration of green light. You can see our emergency vehicle is approaching, and it detects the vehicle, so it's performed green extension, and the yellow light keep blinking. So this is a custom design in this project, and the vehicle has lived. And this is a demonstration of red truncation. You can see this is a red light, right? And after about 5 seconds, it's performed the red truncation and then extend the green time. So all the communication are based on V2X, and this is an isolated intersection. Okay, and the final part of the project I would like to share is the V2X-based multi-model traffic signal priority system in Taiwan City. It is typically a project that extended from the previous one, but in a more larger scale and not in a redeveloped zone where simply no vehicles and human. Okay. The background of the project is that this is the bus map of Route 70. It is the circle route, and we implemented our system in this red area, and the blue line area perform the signal retiming. But the signal retiming is not for bus progression. It's just for passenger cars. So the red line is the system we implemented on, and there are 21 signalized intersections and support active transit signal priority and emergency vehicle signal reactions. You can see this is a busy artery in Taiwan City, so it is a really huge challenge. Okay, so this is the whole scenario of our system. Typically, we install the onboard unit on buses and also on ambulances. And the buses will communicate the traffic controller via ESRC, dedicated short radio communication, V2X communication. And then it's also is equipped with 4G communication, so it can communicate with the cloud platform that is implemented in the traffic management center of Taiwan City. Okay, so it's our roadside unit. So typically we have a V2X communication equipment, and we have a IPC, industrial personal computer, that control our traffic signal controller. And there are onboard units on our buses and ambulances, and they are similar. They have the V2X equipment and industrial computer. Okay, so this is we summarize the challenge of active TSP. It can typically be separated into two types of control. The first one is isolated intersection, and this control type is when the bus is approaching, it's only control the intersection that's in front of the bus, without controlling others intersection. And the pros of this type of control is that the variation of the bus arrival time at this intersection is smaller compared to multi-intersection control because the bus is close to the intersection, so the variation is smaller and accuracy of TSP control would be better. But the cons is if the signal state is not very favorable for the buses, such as red phase, the system usually needs to truncate several seconds to effectively provide transit signal priority for this bus. And the multi-intersection control, the process is more favorable for bus progression because you can control various many intersections at one time and might reduce more negative impacts compared to the isolated control. But the cons is predicting the arrival time at each intersection is more complicated due to the possible traffic variations. Okay, so in this system, in our system, we typically hybrid strategies. First, we have a stage one, and stage one we will control for intersection groups, and we will adjust signal settings at in each intersection group to form a simple progression band that favors bus operation. And the second part, we will control for each intersection because we expect that the bus arrival time at each intersection might not be as expected in the stage one control. So in stage two control, when the bus is approaching the intersection, if there are some time that need to like extend the green for more than 1 second or 2 seconds, we will make a minor adjustment for the signal settings. Okay, so the intersection group is defined as this. So typically, two consecutive bus stops are formed as an intersection group, and this is used for stage one control. And the scenario is that first the bus leaves the bus stop, and then it will communicate with the cloud phone, and the cloud phone will then perform an algorithm to adjust the signal settings of the intersection in this intersection group. And then after performing that, the bus is approaching the first intersection, it will promote stage two control after the bus enters the V2X detection area. So the process is just repeated when the bus passes the first intersection and enters the second intersection's detection area, and then it will perform the stage two control. Okay, and if the bus leaves the whole intersection and enter the next intersection group, it will repeat the whole process. Okay, so this is what we did in the stage one control. We typically use the Webster uniform delay model to try to predict the arrival time of each intersection. So you can see because the time of the bus that arrives at the intersection might have some vehicle queue, and then we can use this formula to predict this estimated bus arrival time. So we separate into three parts: the red light waiting time, the queuing vehicle, the saturation time, and start up those time with the Webster uniform delay model. Okay, the stage two control is in my design, I model the arrival time of the bus at the intersection as a random variable that follows the normal distribution, and there's a standard deviation of this normal distribution, so it will form arrival time interval. So this is L, arrival time interval. So I can calculate so-called passing probability by using the cumulative density function of this normal distribution. So, for example, in this scenario, the passing probability of this bus might near 50. So I use it as a performance measure to determine whether I need to extend the green or truncate the red or just do nothing. Okay, so there's a use a defined threshold to define whether the passing probability exceeds this threshold, and if it exceeds, so there's no need to adjust it, and if it's not, we need to do the green extension or red truncation. Okay, so this is just a scenario of this algorithm. Okay, this is active transit signal priority, and this is emergency vehicle signal preemption, and this is typically the same as the previous one, and the algorithm is simpler. When the emergency vehicle is approaching, we will check the current phase equals target phase or not. The target phase means the phase that the emergency vehicle is asking for passing, and if it equals, so we will just extend the green to the max green, and otherwise we will truncate it and until the phase has switched to the target phase. Okay, so there's a multi-modal competition. The scenario occurs when the ambulances and the buses arrive at intersections simultaneously. So we designed a rule that decides how to deal with such problem. We will first check if the two vehicles has the same target phase, and it is yes, we will just union at the just time. And if it's not, we will check their priority level. For example, maybe the first vehicle is bus and the second one is ambulance. So apparently ambulance has higher priority, so we will switch to service the ambulance. Or otherwise, if it's not, we will just follow first in and first out rule. Okay, so this is a demo video of how of the system. This is the recording on the ambulances. So this is our cloud platform, and you can see this is the location of this ambulance. So when it arrives at the intersection, it will extend the green time, so this is not obvious. And when it arrives at this intersection, it is red light in front of it, so it will just truncate it and then perform the green extension. So you can see it's turned to green. Okay, so this project received several awards, including the first is the highest distinction award from MOTC and Outstanding Transportation Project Award from Chinese Institute of Transportation, and also our system is reported on the local newspaper. And I would like to share, sorry, wait, I might have no time, I will speed up. And before operation, we did a lot of tasks before implementing the system in 21 signalized intersection, because this is a real system installed on a busy arterial road. It is not installed on a redevelopment zone like the previous one. Basically, no cars, no vehicle. So this will have a huge impact on our traffic flow. So we rigorously did the test. Okay, so we first has a test field also in Hsuan-Chih redevelopment zone, and we test the system until midnight. And this is another picture of the test. Okay, so this is what I would like to share. You can see this is me, and I'm smiling, but the situation is that date we have been debugging for a problem for more than 3 hours and still have no significant process. So this is a test scenario on that day. So we there's a checklist, but we didn't achieve none of them. And finally, we find the bug and went home in a minute. Okay, the lessons learned, I think, is the most important part I would like to share. The first one is, I think the complete field survey in the pre-processing stage is extremely important. Because failure to consider adjacent intersections may lead to serious problems. For example, this is our system's coverage. We only implement our system to this intersection we call intersection X, and this is a Hsuan-Chih hospital because the Bureau of Transportation in Taiwan said, the system is only needed to be deployed in front of the hospital. So, but there's a huge problem because there are another 2 signalized intersections, and this intersection only operate during peak hours. And when we did the field survey, we visited here during the off-peak hours, so we didn't know it will operate during peak hours. And another intersection is the timing plans of this signalized intersection coordinate with intersection X. I will elaborate it. You see, this is the field picture of this intersection, and in this field there is a hospital and there's a high left turn volume because all the vehicles, all the patients or doctors, there's a parking lot in there, so they have to make a left turn and park their vehicles. However, there's a signalized intersection here, and the timing plans simply coordinate with this intersection to accommodate this high left turn volume. However, because we did not include this intersection in our control coverage, so when we perform the TSP or emergency vehicle signal preemption, this will disturb the coordination and make a high volume of the left turn vehicles to this intersection, but it cannot coordinate with this, so causing a serious spillback. Also, next intersection is we did not notice this intersection during the field survey because this signal only operates during peak hours. So we also did not include this intersection in our control coverage. So the problem is when we give the preemption to the emergency vehicle is riding from here to here, and the large amount of through vehicles also goes through to this intersection, and however this intersection is not included in the control, so it might be red and it will queue back to this intersection and also cause serious spillback. Also, as I mentioned, my design is to, there's a stage 1 intersection group control, and it will perform transit signal priority in this intersection group. However, what I found in the field is that in a TOD control, there is originally a hazardous progression band design that is not, it's a contradict to my signal control strategy. So it will result in a big problem that after performing the stage 1 transit signal priority, it could not recover the progression of the traffic law could not recover even if the signal has been restored to TOD control. This problem gets worse when the traffic is near saturated because this area is an arterial road in Tainan City. So another example is that these two roads are main arterial, and this is a critical intersection. So originally, the Bureau of Transportation in Tainan designed a progression band of these intersections and another progression band in these intersections. However, because my transit signal priority strategy will destroy the progression band and could not be recovered during the near saturated traffic. So this is another technical issue that our traffic controller has an unclear definition of this effect time parameter. This parameter determines how the traffic light, the subphase, the length of this step will be. However, since this definition is unclear, and there are various explanations among different traffic controller manufacturers, I can mention that there are 3 manufacturers of traffic controller in only one Tainan city. So we encountered a huge problem on designing the system. Okay, here's my conclusions. So my personal lesson and my personal experience is that transportation, do not forget that transportation is a kind of engineering. The series and mathematical models are tools that describe and quantify the complicated real-world traffic phenomena. And but we should not deviate from the reality. We are not a novelist. We cannot conjure up a story without basing on scientific evidence. So, and another lesson I learned is the simulation result may tell a lie if you do not carefully calibrate the traffic parameters. And this is another story, but we have no time to. So hopefully I can explain it next time. And the last one is the field practical experience is a good teacher. I really learned a lot from the field practical experience. And all the lessons that I mentioned earlier seems obvious and trivial, and actually it has been mentioned in traffic engineer books. But you learn it in the classes, it's a story, but when you practically design it, it's another story. Trust me, you will be not aware of these problems if you haven't experienced in practically design of traffic system. So this is my philosophy or my experience that I think transportation research or transportation system is just like a blind man and an elephant. Everyone claims that they know what transportation is. However, actually, no one can comprehend the whole picture. We are just like a blinder trying to find out what the elephant, the transportation is. This is the lesson I gained from the practical experience. Okay, so this is the last part of today's presentation, and my name is Hsuan-Chih Wang. So feel free to contact me if you have any questions. Thank you very much.
So thank you, Mr. Wang. Anyone has questions? John, do you have questions for him?
What are your main contributions? Yes, it looks like it's a good engineering consulting work, but
Yes.
from your theory, every part I don't see where's the contribution, because all you have done has already been the literature more than 25 years ago. Have you read
Yes.
those literature?
Uh,
As your advisor asked you to read those literature or not?
yes.
Can you give me an example?
Yes.
Any of the part of the theory you have presented here are not in the literature.
Yes, yes, I have to admit that actually, just like Professor Liu mentioned, all of this have been presented in the previous literature, and
Even your practice, the
yes.
example, has been in the literature for a long time. Yes, it's good from the consulting point of view.
Yes.
You at least have experience put together, better than a lot of people just know how to do equations,
Yes.
know nothing about real experience. But there's two different levels of practice. One is at the research level. You want to advance your knowledge. Okay. Another level is in consulting level. You want to apply what you know to solve a real world problem. But I mean, I don't want to blame you, but I think your master thesis work, the last one, right? The third project is from your master thesis, right?
that's part of from my master.
How many people involved in that project?
There's about 10 graduate students.
Yeah,
I'm the senior, the most senior one.
And all those are cheap labor, right?
Yes.
All the theoretical part is really textbook material. I can say more than 25 years ago. When I was young as you were, that's already have that kind of theory.
Yes.
I guess some of the things are, well, something that's different. For example, the considering the normal distribution, I guess in Hsuan-Chi's paper, I think he got some inspiration by reading.
Yeah, but not in all the paper. In many other papers, they use a different distribution. Also, you don't have a justification. It's a normal distribution.
Yes.
Variance, okay?
Yes,
Then you
yes,
just,
yes. I can mention that after this, I have made a verification on the normal distribution. Yes, as the professor you mentioned, it is not a normal distribution. It's good left. It's not a bell shape.
it also depends on your volume. I think the whole theory
Yes.
is not about volume's impact.
Yes.
You have, as you finally say, in a saturated condition, then you become a trouble, right?
Yes,
The
yes.
saturated condition, how you going to give a bus priority? How you going to give the emerging vehicle priority? So emerging vehicle priority now is almost, I don't think you can get any paper published in this area, because only in all countries have this problem. In the well-developed country, everyone will automatically let the emerging bus pass, okay? So I reject so many of those papers in IEEE, because it's not a research issue anymore, no. Bus priority, yes, it still could be a job, but your bus priority, I don't think it explore all the priority strategy in the literature yet. What you have done is very primitive. It's good you learn something, you know. So you have to separate from the research and application. But if you simply, I don't see you list a reference either. Yes, I'm not supposed to do it, okay?
Yes.
Taiwan recently tried to go after so many people dissertation without a reference, without a learning experience, because all you have done is mostly has already in the literature.
I can clarify one more thing, because the V2X part, that's some new technology, because the older ones like AVL or check-in, check-out load detector, but they use the up-to-date technology.
So the technology is not new to invent technology. Technology in the connected environment, that's become very popular everywhere.
Yeah.
If your technology, then I give you a credit. It's not your technology. So if you work on the consulting point of view, yes. Consulting, because in Taiwan, the consulting company mostly do not know how to do it, okay? I can say that even those finance company, company, all those companies, I don't think they know really how to do it. But again, technology is not your technology. You do not have innovative application of technology. The one you apply is still a standard. If you look at connected environment, you look at the literature, connected environment is can cover all those applications. So you have to find some way.
Yes.
If you want to do a research, you have to find some way what is missing in your theoretical part. And you somehow get the experience by putting together, but most of your effort, I believe your thesis put on the practical operation, solving those connection hardware problem, right? I don't see you put much of the energy in your algorithm part. You don't agree with me, but I just say, based on the reference, I can see you just learn the basic one and just apply work. Maybe sufficient to your university, but for international level, it's no way to go.
Yes.
It's not bad. At least you know what's going on, okay? You know how to put all the state of practice together. Give him a credit, okay?
So, any more questions? I'll just do one question. If anyone, okay. So, how do you determine the signal group? I guess you divided an arterial into signal group. I'm not sure why you do this and how you determine this.
Professor Chen, you mean the intersection group or?
I guess in one of the slides you said group. I guess it's you show on the map and one group first. And
how do you cluster those intersections in one cluster?
yeah, maybe previous. Okay, maybe the next one. Yeah, why do you do this and how do you determine the groups?
In my original design, I think that the bus will running on the intersection between the two consecutive bus stops without any stop, because if you such as we design intersection group like this, I have to predict the probability of the bus stopping at this stop and the time is consumed at this stop. So that will make the model a little bit more complicated. Actually, I have read Professor John Muir's passive TSP papers that design a progression band favors the bus progression to support passive TSP. And actually, it is how I am inspired by that concept. I tried in the beginning. I tried to turn it into an active one, from passive one to an active one, but I failed to comprehend the complicated mathematical model. So I just adopt a more simpler strategy. So this is what I thought in the beginning.
It's okay, but I tell you, don't believe all those papers published, okay? Even my paper, okay? All those papers published still have a lot of deficiencies, okay? Just have some contribution to get accepted. Nowadays, a bunch of garbage paper already get published. So you have to challenge all those papers, including my paper, okay? Second, let's say you predict the travel time with a probability, but your probability do not involve in traffic volume, congestion level. How can you do a good prediction?
Yes.
This is particularly mixed traffic flow, right?
Yes.
A lot of motorcycle.
Yes.
How can you do a prediction? So you prediction, I don't see any of the such variable including your prediction.
Yes. These factors actually are not included in.
So how does call a prediction? Let's call it intuition based on your simple travel time judgment, right?
Yes. As I see. Yes.
Anyway,
Let's go.
don't be frustrated. Okay, I know in Taiwan it's sufficient, but you should not aim to survive in Taiwan. You should aim to compete in the world stage. Okay, it's not just because you can easily see a lot of those logical deficiencies.
Yes.
So just to clarify, so when you divide the groups, you try to divided by the bus stop, right?
Yes.
Sure. And so, if my understanding is correct, actually you try to do some passive implementation, given it's an active TSP. You try to do something like passive within this group.
Yes.
So basically it's active, but you do some part of passive within the group. This is my understanding.
Yes. Yes. I simply try to form a progression that favors bus arrival in each intersection group.
So you have a bus progression algorithm in your design.
And
It's not look like that. Because you look like just one way, it's not two way.
yeah. It's much more simple than the
One way,
the typical.
One way, there's no need to design. You can use your hand to compute. It's just one way. This challenge is for two way. One way is not a big deal.
Well, I guess the concept can be extended to like two-way progression if this concept is
Of course.
Yeah, so-
two-way model will be more complex.
yes, that's one thing he has to consider.
Yeah, it's okay. It's working. At least it's working. I think your controller there's a problem. Your controller is a dumb controller. It's not a smart controller. The China's controller. I see that. I know that.
Yeah, the standard protocol in Taiwan's controller has not been updated for more than 15 years. So that's a huge problem. That's I have mentioned in the previous class. So that's another huge issue.
Okay, somewhere you talk about dynamic control. I don't know what do you mean dynamic control. There's one part you say the whole structure. Somewhere show the connecting environment, the design structure design. Yeah, there's a huge, the huge structure show your connected environment design. Yeah, here. Somewhere you show your dynamic control. Or you just have picture without the actual research, Do you have somewhere talk about dynamic control?
So you mean which
I
part?
saw you have a terminology, say dynamic control.
Dynamic control.
Oh, go back. Okay, here you have no, last one. Stop. Say adaptive signal
Yes.
control. What do you mean adaptive signal control?
This is just a application.
You know the definition? What's the definition?
Adaptive is as I know, is if there's a four legs intersection and the four legs will it depends on the four legs road, so this can perform the signal adjustment in real time. Compared to the actuated control.
You're just based on your own definition, right? I guess you have you learned from the class, any of the class? What is adaptive traffic control definition? Have you seen anyone in Taiwan?
Yes.
I know in Taiwan definition quite different, okay?
Yes.
Taipei, Hsinchu, and Tainan, Kaohsiung definition are different. Anyway, I don't think you really know what's it. That traffic control yet. Okay, I don't blame you. I know many of your faculty have no idea either. Don't put any terminology in the problem that you don't really know where. You understand? Okay. Professionally, that is a challenge to you. Okay. High risk. Emerging vehicle signal preemption. For emergency vehicle signal preemption, compared with the TSP, in your algorithm, what are the differences?
I think the biggest difference is EVSP has a higher priority level than the consists of priority. So in the algorithm design, we in EVSP typically do not consider the possible negative impacts on non-prioritized traffic. However, in TSP, we do consider these negative impacts.
Really, no, EVSP, because emergency, if you allow for the priority, you have to let the emergency vehicle pass the intersection, right?
Yes.
But the TSP not necessary.
Yes.
You can have many conditions depending on whether they're empty or not, they are early arrival or not. So TSP is a conditional. If you ever no developed country implement EVSP, okay, because that's become a common sense.
Yes.
Only the barbarian country would require this kind of preemption. But it doesn't use absolute preemption, it's unconditional.
Yeah.
Okay, the second one is a condition. So it's quite different. It's not just priority. The second one, you have to consider all the possible conditions, whether it's empty or not, whether it's early arrival or not, whether late arrival or not, right?
Yes.
So it's not necessary also a competition of the different approach, whether you should give a priority or not. Also, you may have more than one bus from different routes. One actually late, another one is early. Okay? There may be different sequence of bus arrival. Especially in Taiwan, you have so many buses. It's not in the United States. So bus arrival is not just one car, one vehicle. You could have multiple buses from different lines. One is early, one is late. So I don't think you consider your argument either.
Yes.
Okay.
That applies.
First in, first out, he mentions.
Yeah, but that's not always possible. It's more complex in Taiwan because Taiwan you have multiple routes of bus arriving flow. But in the United States, other countries, hardly you have a bus fleet come together. Usually just one bus, isolate one at a time, mixed with passenger car. But in Taiwan, bus put come 3 or 4 together, right? I don't know in China, but I know Taipei is very common to see 3 or 4 buses come together. So how do you decide one actually late, one actually empty, one actually urgent to have early arrive before ahead of schedule, right? Because Taipei you have a bus arrival information, so clearly know which one advance. But unfortunately, they could be come in a line, right? So how do you decide it? Do you understand my question?
Yes.
Especially in Taipei, very common now.
Yes, but in Tainan City, the bus is not as prosperous in Taipei, so there's no bus bunching situation in
No, but
Taiwan.
China is a low frequency. So
Much lower frequency. The 13-minute bus schedule is called tight, it's called frequent. So there's no such problems, and multiple bus arrival, we just adopt first in first out rules.
Yeah, but with low frequency, actually not an issue. Just simply based on bus arrival, give them priority. That's all,
Yeah.
because you're not going to impact the delay too much on other approach or track, because as you say, bus frequency is low, so you will not have frequent bus priority activation.
Yeah.
Because we worry about you have too frequent activation, will cause negative impact to the neighboring street, right?
Yes.
If bus is very low priority, then what is the challenge? So my conclusion for you is, when you are doing the research as a publication or as a challenge to your intellectual level, you have to find out where are the challenging issues. Appear to be most of your issues on assembly, put all the hardware together to make sure you're working. That actually should be technician. You should have a technician work for you. Okay? Because spend a lot of time to understand controller is good, but actually fix those problems. So there is not much intellectual effort. It's another just experience. Experienced people can get done quickly. You have no experience, you take a long time to figure out what manner of bug, right? Yeah, okay. It's not bad. That's you can find a good job in the consulting area. In Taiwan, they showed up those good consulting student.
Well, I guess for master student level, that is maybe that's good enough comparing to
Yeah.
his peers.
I think that's otherwise the problem. Okay, to Taiwan, that's otherwise the problem. At least, in my view, you should list clearly all the literature. Okay, then identify which part you're going to follow the literatures and which part you try to adapt to Taiwan. Because in all the literature, we don't deal with high frequency of bus flow. In Taiwan, regardless of which city, overall the bus frequency is quite high compared with United States or other countries except in UK, okay? So you have to at least address those unique traffic flow nature in your study. Then maybe a marginal contribution, but still contribution. But if you completely adopt theory from our traffic scenario, which have a low frequency of bus, then actually when you come to that, my original question is, how do you know your system actually works? How effective it works? Because your work, you have to do it more comprehensively, all possible scenario, to make sure the system actually effective, right? Have you done that? You basically work. It's fun, but work does not mean effective, right? What kind of experiment or the result will give you a confidence that your model actually can, for example, your model works in Tainan, can I transfer your model to Taichung or to Taipei or not? Can you?
We have constructed a simulation to verify it in advance.
You do a simulation, it will take you at least one semester.
Yeah.
Do you agree? Especially, you don't have a good simulation model yet. Include the heavy mixed traffic flow.
Yes.
What kind of simulation model you can have? Which simulation program do you use?
Sumo.
Sumo is a big challenge because it's an open source code, right?
Yes.
So you just to train, to make sure you're working properly, reliably, you can be a master thesis at okay. So you can train the Sumo to do a mixed traffic flow. Yeah, you can have someone do that customized as a student project. So I think you catch one point. Just for simulation calibration, that issue deserve you at least another research, right? And so if you don't have that part, how do you know your system works effectively? And that's only the simulation level evaluation, right?
So that might be done by the student before him, so he can be reliable.
Do you have someone?
I mean, not in his case, but should be someone do the calculation first, and then he can apply.
Exactly, because I think that issue itself is deserve a master's thesis work. You convert the Sumo idea, not modification, to be able to use the heavy mixed traffic flow with high frequency of bus. That's a lot of work. It's not an easy job.
Yes.
Has anyone done?
You mean this group or?
I'm saying in Taiwan.
I don't think so.
I'm not aware.
And then everybody say we use a simulation, we use a simulation. Okay.
Okay, so anyone has questions? If not, let's thank Mr. Wang again.
Okay, not bad.
就是刚一楼进来，我们是楼梯下去，对吧？
做了。好。
是主体，摆着的没有。